Here's 8-65, integrated 3. So it says Spud has a problem. He knows that the roots of a quadratic function are x equals 3 plus 4i and x equals 3 minus 4i. But in order to get credit for the problem, he was supposed to have written down the original equation. So he knows these are like the answers, they're the roots. Unfortunately, he lost the paper with the original equation on it. Luckily, his friends are full of advice. Alexia says, just remember when we made factors from the solution. If you wanted 7 and 4 to be the answers, you used x minus 7 times x minus 4. Use Alexia's idea to write the equation of a quadratic function with which Spud could start. So what Alexia is saying here is that if you had that and you were trying to solve it, you'd set it equal to 0. And then you'd use the zero product property. You'd say, this would say x minus 4 equals 0, so x equals 4. So I get x equals 4 from here, and this would be x minus 7 equals 0, x equals 7. So it's kind of like you're working backwards. Like if these are the solutions, then the factors were x minus whatever the solutions are. So if you use this kind of thinking, then you can just say, I want to go x minus whatever the solution is, minus and then x minus why am I drawing all the weird brackets? Because you kind of have to distribute the negative, but actually it doesn't matter because you've got one of each. But if I just show it, I might not do it this way again, but I have x minus 3 minus 4i times x minus 3 plus 4i. Okay, and then I can just multiply those together and find out what the quadratic was. So to multiply those together, well, I think I'll use an area model box. So I've got x minus 3 minus 4i. So this way is kind of the hard way. X, Alexia's way, minus 3 plus 4i. This is usually the way I do it, though, even though it's the longer version, because it makes more sense to me. So I'm simply multiplying these two together to find out what the quadratic was that they came from. So x times x is x squared, and this is negative 3x, and this is negative 4xi, and this is negative 3x, and this would be 9, and this is 12i, and this is 4xi, and 3 times 4, that's negative 12i, and negative 16i squared. So I'm just going to combine all the like terms, and it turns out usually it's pretty easy to combine them. Some things should cancel out. So this is my x squared. I'm going to kind of like get rid of it to show that I used it up. These two are the x terms. So I have negative 6. I'm going to get rid of those. And then we should have some cancellations, like see how these two, they cancel out. And these two cancel out. And these two, I can combine them if I remember that I squared equals -1. So this is -16 times -1. So this is actually 16. And 16 plus 9, I think, is 25. So I think we get this. So that must have been the original. And then, oh, and it says right here. So then the next part says, Hugo says, no, you can do it that way, but that's too complicated. I think you just start with x equals 3 plus 4i and work backwards. So this way doesn't make as much sense to me, but it's much faster. So now we're going to try Hugo's way. So Hugo is saying on 8-65b, he's saying x equals 3 plus 4i and works. So he's giving us the first part of it. So if that's true, I guess if you subtract 3 from both sides, we got x minus 3 equals 4i. Then, that'll work. So we're supposed to try his method. So he started out with this, and then he subtracted on both sides, and then let's see. We're going to try his method. So I think I would want to square both sides now, because back into a quadratic. I'm just going to try it. Okay, so 4 squared is 16. 16, and I squared is -1. So this gives me -16. And then if I square this out, well, if I square this out, I get x squared. And then this times 2. So minus 6x. Oh my gosh, this is going to be much easier. And then this squared is 9. How's this going to work? And then I add both, and then I can add 16. Doesn't make sense why this works to me, but this is much faster. Didn't that give us the same thing that we got last time? So that must be the quadratic that Spud started with. So we tried Hugo's method. And then letter C says, whose method do you think Spud should use? Explain your choice. So you could say, what I would say is Hugo's way is much faster, but I'm a little afraid I might mess it up because sometimes I forget what to do next. So Alexa's way makes a lot more sense to me, but it takes longer. So answers may vary. So you can say what you want to about that one.